So this is my fourth lecture in the series of lectures on data wrangling with Python. So here there is a prerequisite about NumPy and Pandas libraries. So I have been discussing about the NumPy features and its operations and its usefulness in the matrix, in the array and matrix operations. So in this lecture, I am going to discuss about the array slicing and operations. So let us take a variable data of length 3. So the index starts from 0, 1, 2. There are 3 elements here. 0th index has 1, first index has 2, third, second index has 3. So the data variable contains 3 values, 1, 2, 3. And how you extract this one, how you index this one, data of 0 is 1, data of 1 is middle value here, then data 0 colon 2 means 0 and 1. That means excluding this endpoint, excluding this end index, it is 0 and 1 only. So that is, this is the 0th element, this is the first element. Then this is data starting from index 1. So this is 0th index, 1 and 2. So starting from till the end. So this is starting from 1 here, data 1, data 2. So 2, 3. Then data minus 2, starting from minus 2 to end. So what is minus 2? If you see here, this is the notation. This is 0th location. Then this is the first location. This is the second location. Then this second location is nothing but minus 1. So last element is taken as the minus 1. And this is minus 2. Okay. So why it is, this is minus 2, why it is like this is the data 0 and this is index 1, this is 0th index, this is minus 1 index according to the number line, this is minus index. So basically minus index is nothing but the last one. So it is like a circular buffer. It is like a circular buffer. 1, 2, 3. It is like this. So I have a circular buffer kind of thing here. And let us say this is 0 and this is 1 and this is 2. Okay. So this is 0th element, this is the 0th element and this is the first element, this is the second element. Okay, that is how it is there in the circular. This is called circular buffer and I am representing, that means I am folding this one. Basically I am folding this one. So in this 0th one, 1, 2, again in the opposite direction, in the reverse direction, if I take this 0, this is anti-clockwise direction, minus 1, this is nothing but minus 1 and this is nothing but minus 2. Okay. So this is the, when you move in the forward direction, the clockwise direction, the indices are 0, 1, 2. When you move in the reverse direction or anti-clockwise direction, the indices are 0, minus 1 and minus 2. So in that way, this is what is 0, 0th element, first element, second element is nothing but minus 1 element. That's why it is written here minus 1. Then the other one before that is minus 2. Okay. So because you take it as it is basically modular arithmetic and you are taking on the negative number line. So that's why always in Python the last element here, the last element is nothing but minus 1. Okay. So here what I am showing, I am taking an array of 3 rows and 4 columns. This is first row, second row, third row. So this is a 2-dimensional array basically. So when I print this A, this is the first row, second row, third row, it prints like that. Then A less than or equal to 5. So you are comparing the all elements of A with 5. All elements which have the value less than the 5, they are those elements are taken and assigned a new array here, that is A less I am calling. When I print this A less, so what is this one? This is also size of the same matrix. This is the matrix. Its size is 3 by 4. This is also 3 by 4. But this is a Boolean variable. This is the output of this condition is a Boolean variable. So this Boolean variable is assigned to A less. So here if you see, for example, the 5. This 5 is compared to 1. 1 is less than 5. 2, 3, 4. Up to 5, 4 is less than 5 and equal to 5 also. So 1 to 5, they are all, this condition is satisfied. So that's why true, 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 true and true. So in the same locations, in same indices, I am finding the logical variable true. And this condition is violated for indices from here onwards. That is, this is 0th one, 0, 1, 2, 3, 4. 0 to 4, it is satisfied. From 5th onwards, it is not satisfied. So that is the reason, because A equal to 6. 6 is less than 5, false. 7 is less than 5, false. 12 is less than 5, false. So from here onwards, false, 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 again false, 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 false. So this is this logical operation, this comparative statement basically generates a Boolean variable that is true or false. It is a binary variable, basically categorical variable, and it is 0 or 1 you can say, or true and false. So this is the matrix again, the size is 3 by 4. Now if I use this matrix as the index for the original matrix, wherever true is there, those elements are taken out. So this is the true. Wherever the true condition is there, those elements are extracted from A and they are printed here. Okay. So these are the 5. First 0, 1, 2, 3, 4 are there true. So first 4, 1, 2, 3, 4, 5. So these are the first 5 elements. These 5 elements are printed here. Okay. So basically you are generating a Boolean variable here, and that Boolean variable is used as indexing, for indexing the array from this, and you are forming the new array. Now take another one, A more, A greater than 10. So you know that greater than, I am not describing this Boolean variable again. So this is A more. If I use this Boolean variable, Boolean matrix basically as index here, I will get the 10, 11, 12. This is the new array. Okay. Output of this is output of this is a Boolean array. This array, if I use this condition is satisfied for these elements, so those elements are printed here because 10, 11, 12, they are greater than or equal to 10. Now let us do similar operation. Here what I am doing, divide by 2. So what I am doing here, divide by 2. So what is A first? A is, see here, what is A? A is 1 to 12. Basically it is a 1 to 12 elements are there. So what we are doing here? Here we are dividing by 2. Dividing by 2 means modular arithmetic we are doing here. Modular arithmetic means, so if you divide the element, any element in the A, divide by 2, that is the remainder it will give. So remainder means it will be, if the number is odd, you will get the remainder 1. If the number is even, you will get the remainder 0. So we are comparing the 0. So the remainder should be 0. A modulo division by 2 equal to 0. So this condition is satisfied. So this is again a Boolean matrix. This is a Boolean array. This Boolean array you are using to extract the elements which for which this condition is satisfied. Okay. So the answer is here 2, 4, 6, 8, 10, 12. Out of 12 elements, 6 elements are even. So this condition is satisfied for these elements. So those elements are extracted. You are slicing, basically it is also called a slicing operation. You are slicing some part of the array or vector to use further. Okay. So then take another one. This is A modulo divide by 2 equal to 1. So this is, you are trying to get the odd numbers here. So if you print this output variable div underscore by underscore 2, you have the odd elements here. Okay. Then you take another operation. Here it is a compound operation. A greater than or equal to is comparative statement. Then A is less than 11. So it is ending. You are ending both. So the intersection of these both sets, basically this is one set following this satisfying this condition, greater than 2 and less than 11. So between 2 and 11, excluding 2 and excluding 11, what are the elements which are satisfying this condition? These are the elements. So greater than 2, less than 11. So between 3 and 10, including 3 and 10, you have the array output here as the C. Okay, so note that this total thing is nothing but a Boolean array. This Boolean array is used to extract the elements which satisfy this condition. Okay. Now, so again define a one-dimensional array 1 to 10. I want to slice all the elements with index 3 and greater. 3 to and when there is nothing is given here, it is equal to say that you want to extract the till the end of the array. So here, what is the end here? This is the end here, and this is 0th element, first element, second element, third element. Okay. So from here onwards till the end, that is what we are extracting here. We are slicing out, and there is nothing but 4, 5, 6, 7, 8, 9, 10. Okay, till the end. Now similarly, this is the start index, this side end index. End index was blank at that time. Now you make the starting index blank and column 3 up to 3. So that means from the beginning up to 3. What is the beginning here? 0 is the beginning. 0, 1, 2, 3. But what is the Python notation? It won't. It excludes the end value given here. So that is 0, 1 up to 2 only. Okay. So that's why you got 1, 2, 3. When you print this one, you have sliced the first 3 elements of this given array. So similarly, if you want to slice from the middle of the array, you can use some kind of starting and ending index you can give. So A starting with 4th element to 8th element. So here this 8 is excluded basically. So you are starting from 0. Sorry. So you are starting from 4. Let us see the 4 here. 0, 1, 2, 3, 4. This is the 4th element. You are starting from here. 4th to 8th you are taking. 8 is excluded. So 4 to 7. This is 4, 5, 6, 7. That's why 5, 6, 7, 8 is the output of this slicing operation. Now, let us generate an equally spaced array using arrange. This we have discussed already. So this is one row and 25 columns. Is a single row, 25 columns means 25 elements. Row vector. This is a row vector basically. You are generating using arrange method. This is what. Again, on the generated output, you are applying the reshape method. So reshape method, what it will do, it shapes, it converts the dimensions of the array. Here it is given as 2, 12. That means 2 rows and 12 elements. So totally how many? This is 1 to 25. Actually 1 to 25 means it generates up to 24, and you have these 24 elements, they are arranged as 2 rows and 12 columns. Okay, this is the first column is 12. First row contains 12 elements, second row contains another 12 elements, total 24 elements which are generated here. Okay, so that is how you do the reshape operation. Then H split. What is this H split? You take this X, again 24 elements, and you are splitting in 3 parts. So this one, what is this X basically now? The X is 2 by 12. This is 2 by 12 matrix. So what you are doing, 2 by 12 matrix. So this I have to partition into horizontal split. Horizontal split means split horizontally like this. So how many parts? 3 parts. So naturally, this is the first part, this is the first part, this is the second part, this is the third part, equal parts. So the first part is one matrix, second part is another matrix, third part is another matrix. So basically matrix means 2-dimensional array. So this 2-dimensional array here, 8 elements in the first, 8 elements here. See, this is what, these are the 8 elements. Then another 8 elements here, another 8 elements. So 8 into 3, 24 elements total. Okay. So this Y contains the splitted version. So I can say, what is the dimension of this? Dimension of Y? Now, this each matrix is 2 by 4. Okay, this is 1 2 by 4, another 2 by 4, third 2 by 4. Okay, and what is the index of this? So it is a 3-dimensional. So this matrix corresponds to 0th of the 0th third dimension, 0, 1, 2. Under 0 index you have this matrix, under 1 index you have this matrix, under 2 index you have this matrix. So the dimension of this is 3 by, this is 1, 2, 3, 3 by 2, 2 means 2 rows. So 3 by 2 rows, 4 columns. So basically it is nothing but 3 by 2 by 4 3-dimensional array. So that is how you got after splitting. So this is, again directly we are defining here. We are defining the matrix here again. The matrix is 3 rows, 4 columns. This is the matrix. We are starting from 0. There is no vector here. It is only single index, that is 0. So 0th 1, 0th 1 and all columns. This is row, this is column. Row, column. So row is only one row, that is 0th row, column, all columns. That means this is the 0th row, this is 0th row, then this is first row, this is second row. So 0th row means 1, 2, 3, 4, all columns, column is there, so all columns. So this B1 contains 1, 2, 3, 4. This is output. And now you want to extract this is all columns. So it is a row at index 2. So this is 0th index, first index, second index. So this is the last column you want to extract. So that is how you got 9, 10, 11, 12, the last column here. Okay. Now you want to, this is B1. B1 now, what is the value of B1 now? 9, 10, 11, 12. It is 1 by 4 vector, or 4 element vector, row vector, or horizontal vector I can say. So in this 0th element is this. So I want to replace this 0th element with 99. So this is to be, I am replacing this with 99. So after assigning this 99 to the 0th element, I got the array B1 as 99. This 99 is inserted here, 99. Other things are same. 10, 11, 12. Now, let us see some arithmetic operations. We have again one array 20, 30, 40, 50. I have printed this array. Then I am generating another array. These are called intrinsic arrays, which you need not specify. If you specify the total number of elements, it will give automatically. So you have specified 4. It is a length 4 vector 0, 1, 2, 3. Okay. So this 0 is not index. Don't think that this 0 is index. This is not index. This actual values itself, they are like that. It is starting from 0 because this arrangement starts from 0. 0, 1, 2, 3. So that means 4 elements I have generated assigned to B. So now A equal to this array and B equal to this array. I have taken 2 arrays. I am adding these two. So this is 20 element by element basically. 20 plus 0, 30 plus 1, 31, 40 plus 2, 42, 50 plus 3, 53. That's why 20, 31, 42, 53. Okay, C equal to A plus B. Now D equal to A minus B. So A minus B means A is this 20 minus 0, same 20, 30 minus 1, 29, 40 minus 2, 38, 50 minus 3, 47. So that is what you got as a D. D equal to A minus B. This is what is printed for contained in the array. Then another operation. You have to square this to the power. B to the power of 2. B square. So it is basically element by element. So you know that B equal to 0, 1, 2, 3. 0 square. 1 square 1, 2 square means 4, 3 square means 9. So after squaring, you are assigning to E. The vector E contains the squares of all values of B. Okay, of all elements in the B. Now, let us look into a division operation. So this is a bit complex operation and you have several different things here. You have modulo division, you have integer division and you have real division, integer division and modular division. Okay, modular division we have already seen earlier. So here, this is the normal division. What you are doing? Element by element division. First element of A is divided by first element of B. Second element of A is divided by second element of B, like that. So what are A's here? If you go back and see, A is nothing but 20, 30, 40, like that. Okay. So let us see once again. So this is what 20, 30, 40, 50. What about B? B is 0, 1, 2, 3. So let us come back. Let us do these operations. So here B square is over. So B is 0, 1, 2, 3. A is 20, 30, 40, 50. So 20 divided by 0. Divided by 0 means infinite. Then 30 divided by 1. 30 divided by 1. 30. Then 40 divided by 2. Correct? So 40 divided by 2. That is 20. Then 50 divided by 3. 50 divided by 3 is 16.66. Okay. So that is what. So here I will read once again. This is 20 divided by 0, 30 divided by 1 is 30, then 40 divided by 2 is 20, 50 divided by 3 is 16.66. So this is all basically real division. So it gives, that is the reason, even though this is integer, instead of 30, it is printing as 30 point, that means 30.0. This is 20.0. So this is called real division. Then take another kind of division. That is A. You can say that this is integer division or truncation. After division, whatever you got is truncated towards the lowest integer. and it is also called as floor division. It is also called as floor division. So first what you are doing? 20 divided by 0. Yeah, this is 20. So here, yeah, it is. So it is A means 20. 20 divided by 0. So integer it is. It is converting into integer 0. Then 30 divided by 1. 30. I mean, same thing you can take. Same thing you can take actually. This one. This is real division. Then truncate this directly. So infinite, after truncation it is taking as the 0. So it is taking like that. Then 30.0 is taken as 30 integer. 20.0 is taken as 20. 16.66 is taken as 16. So it is the basically truncation. Now, again, I am showing this A vector, same A vector I am taking again, and B vector what I am doing, np dot arrange, that is 4 elements 0 to 3, 0, 1, 2, 3, and plus 2 I am adding. So when I add plus 2, what is happening? 0 will become 2, 1 will become 3, and similarly 4, 5 you will get. Okay, so it's starting with earlier it was 0 to 3, now it is 2 to 5 because you have added 2 to each element. So consider this B, then A divided by B, same operation, real division this is. So 20 divided by 2, 30 divided by 3, 40 divided by 4, 50 divided by 5, all are tens only. So that's why 10.0 decimal. So it is 10.0, 10.0, 10.0. Now take another division, this is floor division, and in this one A equal to 20, 20 divided by 2, and this was 10. So basically this same result here also, same thing, but it converts this into integers. Integers, lowest integers it converts in. So 10.0 means 10. All elements are 10 here, 10.0. So all elements are converted into integers 10. Now A modulo division by B. So 20 divided by 2. Go on subtracting the 2 from 20. What is the remainder ultimately you are getting? You get the remainder 0 here. Similarly, if I take 3 here, second element B, second element is 3. 3, you are dividing this 30 by 3 by using modulo arithmetic. So this is 3 tens are 30, remainder is 0. So similarly, other things also. 40 divided by 4, modulo arithmetic, the remainder is 0. 50 divided by 5, remainder is 0. So that's why you got all zeros here. Okay, so H is all zeros. Now, again take this, and up to this I think we have done already. Now I am adding one value to B. B plus 1 I am taking. So what is B actually? B is nothing but 2, 3, 4, 5 here. So when I add 1, B plus 1 becomes 3, 4, 5, 6. So 3 to 6. This is nothing but 3 to 6. Now take A. A is 20. 20 divided by B plus 1 is nothing but 3. So 20 divided by 3. 20 divided by 3 is, how much 20 divided by 3? 6. 20 divided by 3 is 6.33. 6.33. So sorry, this is remainder. So this is remainder. So 3 you are dividing by 3, and remainder you have to see. 3 7s are 21. 3 6 are 18. The remainder is 2. That is what is taken here. Now second element is, what is the second element here? 30. And what about the second element here? B plus 1. 3 plus 1. 4. So 30 divided by 4. 4 7s are 28. 4 7s are 28. The remainder is 2. And third element, B. B is 4. 4 plus 1 is 5. So you have to divide 40 by 5. So 5 8s are 40, remainder is 0. Now B plus 1 again. So fourth element is 5. 5 plus 1 it is 6. So 50 divided by 6 you have to do. So 50 divided by 6 means 6 8s are 48 and the remainder is 2. That's why you got this remainder vector. This remainder array is nothing but H. Okay. Now see another operation. Same thing 1 2 1 2 3 4 another 4. Total 8 elements are there. I have created an array A with 8 elements. One of them is minus also. Okay, and these are all random numbers. They are not successive. 1 2 3 4 5 6 up to this successive, but afterwards minus 10 and 3. It is distorted. So you cannot say they are uniform. Continuously increasing numbers. They are random numbers. No. Now what you are doing? You are taking the 7th up to 7th. This is starting is blank. So from the beginning up to 7. Up to 7 means this is the 0th element. 1, 2, 3, 4, 5, 6. And 0 to 6 basically. Here it means 0 to 6. 7 is not included. So 0 to 6 means 1 to minus 10. This is what 1 to minus 10. This is copied and to the B. So you are assigning the first 7 values to the array B. Okay. So this is the array, new array. Now what you are doing? Take this B. This is the B you take and subtract 4 from it and again reassign to the same original array B. So minus 4, minus 1 minus 4, minus 3. This is the B output, correct? This is the output is printed like this in Python. So this is 1 minus 4, 1 minus 4 is minus 3, 1 minus 2 is minus 2, this is, 1 minus 4 is minus 3, 2 minus 4 is minus 2, 3 minus 4 is minus 1, 4 minus 4 is 0. You are subtracting 4 from all these things. Okay. So that is what you are doing here. B equal to B minus 4. So in this is the B. I am subtracting 4. When it comes to 6 value, what is that you have to do here? This is 6 minus 4 means plus value. Here minus 10 minus 4. So minus 10 minus 4 is minus 14. So this is what you have after subtracting 4 and assigning the values to the same array again. So this is what minus 3, minus 2, minus 1, 0, plus 2, plus 1, plus 2, minus 14. So this is what you have the B. Now np.abs, absolute value. You can take absolute value for B. If I take absolute value, what will happen? The sign will go away. Minus 3 will become plus 3, minus 2 will become plus 2, minus 1 becomes plus 1. Other things are same. And here I have minus 14. Minus 14 will become plus 14. Now, so this is what you have. And this absolute value you are just printing. You are not assigning this to B. So new array is not formed here. So np.absolute B means absolute values of this. That means ignoring the sign. This is what you have. Then B. Where is B? B is here. This is the B. Here it is only printed. So B actually is not modified. It is same thing here. Now what you have to do? Sum of B. np.sum. Add all these elements. Minus 3, minus 2, minus 1. Up to this it is minus 6. Minus 6 plus 0. So you are adding. So up to this minus 6 plus 0. Minus 6 plus 1. Minus 5. Minus 5 plus 2. Okay, minus 5 plus 2. Minus 3. Minus 3. Minus 14. So the total sum is minus 17. Okay, it is minus 17. Then again print the same vector. 1, 2, 3, 4, 5, 6, minus 10, 3. So you have added, this array It is there. Here itself it is there. So, it is not the original one only. Then cumulative sum. Cumulative sum means you are adding sequentially all the values. Okay. Progressively you are adding. So, if this is the array 1 I have printed here, cumulative sum, 2 plus 1 up to this 2. So, 2 plus 1 is 3. So, this is 1. 1 plus 2 is 3. Then 3 plus 3. Up to this is 3. Then 3 plus 3. 6. So, up to this is 6. 6 plus 4. 10. 10 plus 5. 15. 15 plus 6. 21. 21 plus 21 plus minus plus of minus 1. So, 21 minus 10 I can say. 21 instead of plus I can say minus 10. So, that is equal to 11. Then 11 plus 3, 14. So, 11 plus 3, 4. That is a cumulative. So, progressively up to first element, up to second element, up to third element like that. Now, append operation. I have taken the same vector again. It is size of 4 elements, 4 in total, 8 elements, 0 to 7. Now, that's why length of A is 1, 2, 3, 4, 5, 6, 7, 8, 9. So, here, because you have appended, sorry, this append I have to discuss. Appended 10 here. Appended 10 to this. So, it is already 1, 2, 3, 4, 5, 6, 7, 8 elements are there up to this. And you have appended this value 10 at the end. That is what you have done here. Now, when you see the length, 8 has become 9. Now, we want to find the, let us say we want to find the median of this vector. So, median of this vector, it is showing as 3. It here also, again, same thing, because same A has not changed. Now, how you will find the median? You have to first sort this array. Given array must be sorted. So, this is what sorted. Sort A, np.sort A equal to md1. So, what is this md1 variable? You are sorting in the ascending order minimum value to maximum value. So, what is the minimum value in this? Minus 10. So, minus 10 has come first. Afterwards, 1, 2, 3, 4, 5. 1, 2, 3 is there here. 1, 2, 3. Then this 3. Okay. So, you are basically, after appending 10, you want to find the median. So, median means you have, how you find the median? Total 9 numbers are there. You sort it out, and in the middle value, whatever 50% percentile, that is nothing but that means below the median, all elements, below the elements, number of elements which are below the median and above the median, both are same. That is in the middle basically. So, after you sort it. So, in the sorted one, you have, I think is that function. I will discuss this one later. So, this is median of the A is 3. Of course, this is same thing repeated here. Then let us do by sorting here. So, I am sorting A first. When I sort here, lowest value has come here minus 10, 1, 2, 3, and this 3, and this 3. After that, only 4 comes basically. So, 1, 2, 3, 3, 4, 5, 6, 10. Okay. So, this is what you have after sorting. So, minimum is minus 10, maximum is plus 10. So, total number of elements are 9. So, this is nothing but standard deviation. NP dot standard deviation. So, NP dot standard deviation of A. So, what is standard deviation of A? We are getting 4.6837. We are getting this value. And how you find that one? A is a vector. Find the mean value. Then subtract this mean value from A minus mn. So, I think it is there. Yeah, it is. It should be actually. It should be mean. Actually, it should be. So, I have repeatedly put this one. So actually I should put mean. So if I find mean, I am calling that mean as Mn. You subtract the mean from A, then I am calling that array as Am. Am equal to, this is the array. After subtracting the mean value, this is the array I got. And afterwards, what I am doing, Am square I am doing. So when I square this vector of length, how many are there? 1, 2, 3, 4, 6, 7, 8. Okay. So here in this one, only 8 elements are there because I have not shown the extended array here. Okay. The original array I have taken, it seems. So this is 8 elements and minus its mean value, you will get this one. So A minus, this is A minus mu. And afterwards A minus mu whole square. You are taking the square of that one. So all these negative numbers will become positive numbers. Okay. These negative numbers will become positive numbers will remain positive numbers. Now what you are doing? You are squaring each element. I got 8 elements here. Each element you are squaring. Then after squaring, see here, after squaring I am summing. So I will get a single value divided by length of here, divided by 8 here. So I will get the answer. So that is nothing but MS. So whatever I have done so far, what is that I have done? Find the mean, subtract the mean from this, then square this one and divide this one by size of array, that is length of array. So if I do that, I am getting 21.9375. This is mean square value actually, because I squared it and found the mean by dividing them by its length. So you found the mean, mean square value. This is squared value. Okay, yeah, and the sum divided by this. So it is mean squared value. Mean squared value is 21.937, and if I find square root of this one, np dot square root of this 21.9357, I will get the standard deviation. That standard deviation is nothing but 4.6837. So whether you found manually like this or directly by using the NumPy method, you can find the STD. In both ways, you will get the same answer, that is 4.6837. Here also 4.6837. So today what I have done is I have reviewed array indexing and slicing and some operations on the arrays. Of course, at the end I also did some derived some statistical parameters like mean, median, standard deviation. These are 3 parameters I used. I think I will continue this. I will continue with my lecture 5 tomorrow, and in that one I am going to discuss about the matrix operations. 2-dimensional, they are totally purely dependent on the matrix operations. So it is nothing but linear algebra by using NumPy matrices. Okay. Thank you for your attention.
Like, share and subscribe. Hit the bell icon for more updates.